So this part of today's masterclass series, this is your data. Query it as is. So basically, this is an introduction to the concept of data lakes. Fortunately, my audience is well educated, and some of this stuff might be a little bit too elementary or rudimentary. Keep you all grasped and paying attention, but we'll go through it. So the concept of data lakes. I guess it takes time to this thing to connect.
Yeah.
Data lakes is basically just it's just one component of your overall big data strategy. Data lakes provide you with the ability to store your data in its native format and pretty much query it as is. If you've never really thought about data lakes before, or even considered with what the concept of querying your data as is, what you could perhaps think about is on your PC, laptop, Apple, the ability to go into a file directory, type into the search bar, and search on the file name, or even more precisely, the contents of the file. Now, back in my day, after COBOL, you'd get a search that might complain that, hey, the OS has not indexed your files, so your search might be slow. Or if you were savvy enough to have indexed your files, you'd see that by typing in your text that you're searching for or a tag on a file, that file pops up immediately, right? So imagine that scaled out onto a super level. And essentially, functionality behind data lakes, that's what we're driving towards. The ability to search against your data in its native format. So Farouk, I was saying that you really don't have the ability to cheat with this thing. You can't look at your notes on the PowerPoint slide. You just gotta go for it. So we're gonna cover these topics. What is a data lake? Why even use a data lake? We're going to address the architecture of a data lake, some key concepts. We're going to understand what the difference is between a data lake and a data warehouse. We're going to explore some of the benefits and risks associated with implementing a data lake. And then finally, we want to cover some of the best practices. All right. So an introduction to who I am. I've been introduced as Gerard Sanders. I've introduced myself as Shahid. I prefer to go by the name Shahid. So I have G. Shahid Sanders. So I got both of them up there, so you know who we're talking about. Why am I here? I'm here really because I believe in the empowerment through technology. And to piggyback on all of the things that my brother Farouk has already shared, I truly believe in explaining technology to other people so that they can understand it and use it for themselves in order to realize their next big idea. Just over the past 5 years, if you've been really paying attention, there's been a number of advancements that have allowed everyday people pretty much to educate themselves on the basics of how to use this technology and know enough to bring together the right amount of people to produce something truly great, truly game-changing, truly disruptive. And it not only makes people's lives easier or expose them to new things, but in the pursuit of that passion, it's made people a lot of money. And not to get too much into a tangent, I'm not a person who believes in doing something for the sake of, so I guess backwards is forwards and forwards is backwards. Great. I'm not a person who believes in doing something for the sake of the money. I kind of believe that if you put your heart and your passion into something, the money is going to be a side effect of it. And I think if everyone kind of approached their lives in that way, they would be all the more richer as a result. So, what is a data lake? A couple of key concepts about what a data lake actually is. A data lake is a place to store every type of data in its native format. This can be a flat file, text delimited, CSV, even raw content, Word documents, Excel spreadsheets. It could even be your actual database files that are fed into your relational database management system, JSON, the list goes on and on. It's a way to store all of the data for an organization to process later on. We'll talk about different storage solutions. Hadoop comes up pretty often. The architecture of Hadoop allows for one to store all of their data in a way that the architecture atop of it can bring back the information found in those files in a very fast and efficient manner. And then the data, as it differs from a relational database management system, the data is all flat. You don't necessarily see all of your relationships established in the data lake. As we've stressed and as we've discussed in all the other topics before me, your relationships, your structures, all of that is defined after your data has actually been landed, rather than before, as you would have with a SQL database. So that's a little bit on that. And I want to make sure I'm not missing anything, so at the risk of being a little tacky, look at my notes. Okay, I think I covered all of that. So let's get into why we use a data lake and how do we benefit. We use data lakes to offer up a raw view of our data to our data scientists. It gives them an opportunity to see relationships that we couldn't think of at the time that the data was actually produced. Now, data lakes typically are settled, meaning you're not looking at impacted data so much in real time as you are looking at data that had been generated a short time in the past. And that kind of alludes to the relevance of the data. And we'll get more into that later. We use a data lake to improve the quality of data analysis. We also use data lakes to improve our business agility. So through the analysis, we're able to make, in a lot of cases, near real-time decisions, predict outcomes, and make adjustments on the fly based on the events that are happening either right now or maybe a few moments ago, but within a relevant window of time. These predictions can make money. And of course, making money gives your company a competitive advantage. And lastly, the concept of a data lake is that your data is not closed off. And we had a brief discussion about that where, one team might own the data, they're restricting access to another team. But as we've already kind of drove home the point that the data belongs to the organization and is for the benefit of the organization. And the data lake allows us a way to facilitate that. Data lake architecture. And you'll see a lot of some of the things we've covered earlier in the day. So you have your data sources on the left-hand side, and we travel over to the right-hand side of the screen to see the actions that are taken as a result of that data. In the middle, we have an ingestion tier, and the ingestion tier happens in 3 stages: real time, micro batch, and mega batch. Your real time consumption of data, you think about things like data streaming using tools such as Kafka. For AWS, we have Redshift, different tools of that nature. For micro batches, we think about whole data sources, right? On regular intervals, 5 minutes, 10 minutes, message queue systems, message notification systems, and of course, mega batch processing. And this is something that typically tends to happen in your larger corporations. They'll produce a data set maybe at the end of the day, then your process picks up first thing in the morning, processes the data, and makes some information available for some end user the next day. One of the scenarios where we see this often is processing advertisement analytics. So for Cox Media Group, they sell different ads on their websites, on different ad platforms such as Facebook, Google, things of this nature. And whenever they implement an ad campaign, someone goes out and creates the ad on this platform, and it has to run from a start date to an end date. During the life cycle of that ad, we have to pull back the metrics on it. So if your ad runs today, from 12 from the first hour to the day to the last hour of the day, it's being showed to different users. It's gathering impressions information, it's gathering click information, and other metrics. This information is then made available the first hour of the following day. So yesterday, you see, or rather, you see the ad information that accumulated the day before, yesterday. And let's say your ad had 1,200 impressions. Okay, so you pull that information into your data lake, you ingest it, and it's there. Well, if you pull for that same day, following day, so that's today minus 2, that 1,200 may actually change to 1,500 impressions, right? So your data has been impacted. So you have to reflect that change in your data lake. And we discussed several ways of doing that. but that's just an example of how mega batch processing affects your data lake, and that's a use case in which you would execute something like that. So this middle block, we start from the bottom down here, circle 3, number 3, working our way up. HDFS storage, that's Hadoop. As I already mentioned, it has all of your data. It's flat, it's unstructured, sometimes it's structured. It's in databases, it's in files, maybe it's in emails. You have a distillation layer. That distillation layer speaks to your ETL. If you're familiar with Microsoft technologies, your ETL is usually done in SSIS. If you work in the cloud, to give you an example, maybe in AWS, you might use the glue services with some Python code to actually do your ETL, right? And then we kind of work our way up to the processing layer, the processing tier. The processing tier kind of interacts with your workflow management, and these are just steps that help normalize that data and get it ready for the end-using systems, right? So our data scientists, they had a chance to look at the raw data. They saw the relationships that they want to come out of that. They create the relationships, code the ETL layer, and then what's output from that are files that contain the information in ready-to-use formats that can be ingested into Tableau or some sort of business intelligence layer, or it may actually feed some dashboard that other analytics can be performed against. Then you have your insights tier, moving over to the right. The information that was produced and distilled up can now be ingested and stored in NoSQL databases and SQL databases. It can be processed through map-reduced layers, right? And basically, this insights tier is where your process data lives in a programmatic way that can be ingested by your business intelligence tools, your reporting engines, maybe Tableau once more, maybe BI Power Apps by Microsoft, and your data analysts can actually visualize the data. So essentially all that to say, this is where your data will actually be visualized. And I want to come back up to this number 6 block, the Unified Operations tier. This is where your data governance is actually going to take place. We're going to enforce our security there. So not everyone can access that information. All of your security protocols are actually implemented in that layer. We can make the data points available to just those entities who we want to see and consume that information. And we can restrict others. In addition to that, we have a place where we can watch the entire system to see the health of how our processes are running, to make sure that there are no failure points, and if there are, we can identify those areas of failure very quickly and resolve issues in a timely manner. So that's the overall architecture of the data lake. And this is not the only way to architect a data lake. This is an example, but any data lake should address those key points. Your data sources, the timeliness on how that information is going to be ingested, the way you're actually going to store that raw information, how you're going to process it and extract information to make available, your governance on top of all of that, security, who can access it, who cannot, which tools you're going to use to actually help you apply the business rules, to finally visualize the data to the end users. So from that, are there any questions? Right, it's exciting stuff, riveting, riveting. So our key concepts. I'm gonna tell you what, I'm about to skip over this guy because all my notes are under this. You have 9 different areas in a data lake. A lot of this information is redundant, but we'll take a shot. Security. Can't emphasize that enough. If you want to control who's accessing your information and you want to protect the different data points that is sensitive not only to the entity that created that information, but as well as to those who actually consumes that information. Data governance. We want to maintain a set of rules that help ensure the data quality, which is the next circle to clockwise from data governance. Data discovery. This is the cataloging that we talked about earlier. The ability to go into your organization, find all the different points of data, and make it available to your organization. And more importantly, knowing what it is that you have to offer. Data auditing. This is a concept where we track who is changing the information, when it's changing, and knowing that information, again, helps us to preserve the actual quality. Data auditing, you'll hear that mentioned as data lineage. It's knowing who produced the information, and between the time it was produced and the time that you're seeing it, how many times it's changed, and who's changing. Data storage. How is this information stored in a way that makes it readily available to other entities in other stages and other systems that need to coordinate and process that information. Data lineage. Again, that is the result of data auditing and, I guess, ultimately, data governance. And data exploration, that is akin to the data discovery. Data exploration is the work of our data scientists. They look at what's there and they find relationships in order to get new information. Data ingestion, that's how the data gets into the data lake. And ultimately, teamwork. This is one area that cannot be stressed enough. Teamwork is necessary in all of these stages in order to be good stewards of the information that we're storing in our lake. That data that you collect only has a short to moderate period of being relevant. If you think about in your day-to-day life all of the events that are taking place, even with you sitting down here watching right now, you have metrics that you can derive. How many times you blink in a second? What is your heart rate right now? How many times you're taking a breath? What is your blood pressure? What is your body temperature? All of this, we're just sitting down right now, creating events. And if you had monitors on you, this information would be tracked and logged somewhere, somehow. Just as your body vitals are important to you, the data that your organization generates is important to it. It's the way that you can tell what's happening right now, what changes you need to make in the immediate short term, and it gives you an opportunity to see how you've performed over the long term. Are you trending in a positive direction? Are you crashing and burning? What type of changes you need to make right now in order to stay relevant and to save your life. Just right now, if your body was creating events, your arm would go numb, you feel pain in your chest, and you know you're having a heart attack. These are events that are being generated. This data, if it was being collected, someone will be able to analyze it very quickly and say, this individual is having a heart attack, and there are other processes that need to take place in order to save this individual's life. Does this individual have some sort of medication that they can take right now to help stabilize the situation until we can get them to the hospital? Your data that's generated by your organization or by a business entity is no different. So, said data lake probably 1,000 times. What's the difference between a data lake versus a data warehouse? And there's a significant difference. I think one of the first things I would note is that a data warehouse could generate artifacts that could actually live in a data lake. But without getting too wrapped up into weeds here, let's go over a couple of differences. So the data as a parameter of a data lake or a data warehouse. Your data lake stores everything. Your data warehouse only focuses on the business process. So the data in the data warehouse already has a specific business context around it, versus in the data lake, because it's storing everything, the data is raw. It represents the potential for someone to go in and find information and establish new relationships between the data to derive at some business purpose or a set of business purposes. The processing. The data in the data lake is mainly unprocessed at that point, where it's introduced into the ecosystem. It's ingested, it's brought in, it's landed, but pretty much that's it. Data warehouses have highly processed data. It's already been transformed, it's already been generated into some sort of cube, and it's been optimized in order to answer the questions that will be asked of it. Your type of data, it can be unstructured, it can be semi-structured, or it can be structured. Your data warehouse is already, for the most part, structured in some sort of tabular form. In data lakes, there's a shared data stewardship. In data warehouses, the data is already optimized for data retrieval, as I mentioned earlier. In terms of agility, data lakes, the data is highly agile. We can configure it and reconfigure it as needed. Compared to a data lake, it's less agile. It already has fixed configuration. And we understand better how that configuration comes into play as we get to some of the lower parameters as we go down the list. Your users for data lakes is mostly data scientists. Your warehouses are usually consumed by business professionals and is widely used. The storage takes place in a system that's designed for low cost, whereas with data warehouses, your business, it's more expensive, and it gives a fast response times that's used, but there's already a commitment of dollars and resources that go into that data warehouse, and that cost is there whether or not that data is used or remains unused. Now, as far as security is concerned, the raw data lake itself offers lesser control. Your data warehouses allow for better control because it lives inside of some sort of relational system that you have to have some sort of user account to access to begin with. replacement of EDW, or it can be complementary, as opposed to being complementary to EDW, and not exactly a replacement. Your schema. And this is something that when I was first introduced to data lakes, it was a little difficult for me to wrap my head around. But the schema is on reading. There's no predefined schema for a data lake versus a data warehouse. It's a schema on write. So when you consider when you push data into a data warehouse, you already have to know the data types of each of the columns before it can be written to that table. If you write a string into a table field that's been configured as an integer, you'll get an error, and that write won't happen. Whereas with a data lake, we don't care. We just land that data. Once it lands as a member of that data lake, but when we want to go in and extract it, then we tell the system how to interpret that field or that column information or that data blob. And we know the schema on read. Almost done. The data processing for data lakes, it helps with fast ingestion of new information. Why? Because all we're doing is we're landing this data into a system to store it. Whereas with data warehouses, there's a lot of steps that have to go into consuming that information or that data to store it in the data warehouse. Data granularity. The data is raw. I don't think you can get any more granular than that for a data lake. The data is as it comes. Whereas with the data warehouse, it's already summarized, it's already aggregated and rolled up to tell the story that's desired. And then your tools. Tools for data lakes can use open source tools like Hadoop or MapReduce. Whereas your data warehouse, the tools used to interact with it are mostly proprietary or commercial tools. So, before I move on from this, are there any questions? Hearing none, I shall move on.
Excuse me.
Yeah.
And getting data into the data lake. Now, I understand the data warehouse, which is based on the table structure. Now, you said this one is not based on table structure. Then how does it save it as a string?
It saves the data raw, as is. So let's use Hadoop as an example. Let's use the use case that we want to interact with a system that keeps up with all of the pixel data that's generated by Google for your website. You go to Google, you ask for all of your information from the month of January. We pull that information down as JSON, raw JSON, and we save it to a file in Hadoop. We partition Hadoop. We say, hey, Hadoop, put it in a folder, label it January, put this file inside of the January folder. For February, we do the same thing. February, file. March, folder, file. April, through the end of the year. So at the end of the year, you have 12 folders. Each of them have one JSON file of all of that month's data. Okay. This allows Hadoop to know where to look for information that you ask of it and serve it up quickly. If you remember that example that I gave you at the start of my talk, when you go to a search window in your folder on your PC or laptop, and you start typing in something in the search, it pulls that file up almost immediately. It's exactly the same concept. But at that time, you're not saying select all files with junior in it, you know, you just
type
it and it
and
comes up.
together.
Yep. All right. The benefits and risks associated with a data lake or implementing a data lake. Your benefits. It helps with advanced analytics. It's cost effective. It has the attributes of scalability and flexibility. It offers value from unlimited data types. And really it offers an opportunity to gain some value from data that you may not have otherwise used or leveraged. It reduces the cost of ownership. The system intrinsically has an economic storage of files. Data lakes are quickly adaptable. The key benefit is that it provides centralization of different data sources. And once again, it's flexible in the way that it allows access to that data. It's something that's often referred to as, hopefully I don't get tongue-tied on the word, data democratization. Democratized, I got tongue-tied on it, forget it. Anyway, it has the word democracy in it anyway. The risks associated with the data lake. Well, your data lake may lose some relevance. Like I alluded to earlier, there's only a finite amount of time that the information is relevant in a data lake. Just as time passes, well, the moment that we experience time, that is, we meet the future, the events that happen in that point in time immediately becomes the past. My words from this talk will only be relevant for the duration of my speaking. Maybe some of the concepts that I'm sharing with you will be remembered tomorrow. Maybe it'll cause you to act on something next month. But for the most part, the time has passed. Well, same thing with the data lake. You have to bring that information in. You have to get it ready for your downstream systems, and the information that's there will be relevant only for a period of time. That is, only for a period of time that you're actually interested. There's a higher risk involved while designing. So what are some of those risks? It can get messy very quickly if you do not go into the data lake design process with the key concepts in mind. There's an opportunity to invite and govern chaos with your data. There's an opportunity to invite unusable data. And then there's an opportunity to have a hodgepodge of different and complicated tools stepping over one another in order to leverage the data that's coming out of your lake. And that also speaks back to why teamwork is very important. Right? So in some instances, it increases the storage and compute costs. And this is taken into account on how you actually utilize resources to implement your data lake. There's a cost with hosting Hadoop on-prem that you have to take into account. And it has to make sense for your business. Just as there's a cost with implementing your data lake in the cloud. If you don't design the subcomponents in the right way, you can end up spending a lot of money, and it may not be worth the result that you're actually getting from it. So there has to be a measured and educated approach to designing your data lake. There's no account of the lineage of findings by previous analysts. So a group of analysts go into a data lake, they produce some data sets out of it from their understanding of what's there and their processing of the information. Oftentimes, the information that they extract from that data lake, it's of use to them and possibly could be used to other organizations or to other people, but generally, that data is consumed by them and it sits somewhere unused. What Farouk spoke to as a featured part of Qosil, it allows that data scientist to put that his results and his findings back into the ecosystem and allow it to be discoverable by other people who could benefit from it. So I just wanted to note how that particular risk, as well as other risks that I've covered already, we've actually gone into this whole thing with that thought in mind to mitigate it on the onset and not as an afterthought or on the back end of it. Last but not least, security and access control. You have to design your systems in the data lake with security and access control in mind, because the tools that you use will not do it for you. All right? So this is the last section, best practices. When designing your data lake, you have to keep in mind these best practices. It goes a long way to avoiding some of the pitfalls that I've discussed in earlier slides. So when you design your data lake, you should consider that it must support native data types. Support native data types. Strings, integers, Boolean, nitty-gritty data types such as that. Once you apply your domain logic, that is your business context, onto this data and you process it downstream, then you can extrapolate more complicated data sets or data types as a result of that data analysis. Your data lake should be driven by what's available. This is why cataloging your data is key. It tells you what's available and gives you all the information that you need in order to address this particular practice of designing a data lake. The data lake should be integrated with service APIs. And it kind of goes without saying, at the service API level, it allows you to implement some of those other tips that we spoke about around access control, governance to the data. And your service APIs can assist with implementing that business context and schema on read that we spoke of. You should keep the stages of processing separate. You don't want your system to fail just because one part of the processing is not working. Your new data should be integrated quickly. So as I said time and time again, there's only a certain period of time where the information in your data lake is even relevant. You should implement domain-driven design or business context. There are things around a given domain that is crucial to understanding the data. Just as I gave the example of an individual sitting down and all of the different data points that they're generating just by breathing and existing, that has a certain context. If you're running a coal company, there are things that are happening with your business. It's generating events. You have workflows. There are processes that are being implemented. And when they're being implemented, it's generating information and data that you, as a data lake architect, must take into consideration because it greatly affects and directly affects how your data scientists are able to get into there and do their thing in order to make this make their derived data sets even possible. And of course, last but not least, you must support existing data management rules. These rules help keep the data reliable. It helps maintain the integrity of the data. It helps make sure that the decisions that you make for your business are the right decisions. It'll be horrible if you decide to pull, say, an ad from Facebook that perhaps may have been generating your client millions of dollars because something happened in the process that may have reflected that the ad was actually performing poorly when indeed it was performing well, right? So, because some data management rule was not followed, there was an opportunity for some misinformation to get in there. Let's think in our day-to-day lives, how we might make a decision based off of some sort of misinformation, and we end up in a worse position. Only later to find out that the information or the intelligence that we acted on was incorrect. So in summary, the data lake is a storage repository. It offers an unrefined view of data. It's a unified operations tier, processing tier, distillation tier, and HDFS. Data ingestion, data storage, data quality, auditing, exploration, and discovery are some of the important components of data lake architecture. We spoke about the design of the data lake and how it should be driven by what is available, and reduces long-term cost of ownership and allows economic storage of files. And then lastly, we just got finished discussing some of the biggest risks of data lakes, and we mentioned that security and access control all throughout the presentation is what we should consider as some of the one of the biggest threats to the data. Because if the data is not right, then the decision that you make as a result of it will be incorrect. All right. I don't know how much time has passed. I don't have any more saliva in my mouth. I'm done. So if you have any questions about this or any other thing that we've discussed during the course of the day, now is an excellent time to present your questions. Challenges to information or anything like that. So I'll ask you guys questions. So what are some of the challenges you may think of in implementing a data lake in your organization? Understanding some of the points that I've just gone across. And anybody have any thoughts to share on that?
We tried off to show the business to prove value. I mean, of course, in comparison with the traditional just database. What is the first argument to invest in the data?
Well, you have to talk to business in their own language. They might not understand technical context of what the advantages might be. you have to explain it in a way that helps them understand how a data lake will actually help them solve their problem. If they have goals, say they have goals for the third quarter of this year within your domain. And in order to get there, they've budgeted a certain amount of revenue to come into the company. Well, you understanding the business domain, you might understand that because of certain events in the fulfillment of the business task, a lot of money is being spent, right? Let's say a shipment from a vendor. There's a group of vendors that are very hard to get in contact with, and it's hard for them to process the orders and the purchase orders that you send them, right? So you have some projects that are down the road that is crucial on that vendor delivering to your company, getting the order right, and delivering it on time. Because you have these sales projections that you have to make by third quarter of this year. Well, a data warehouse may have told you some bit of information based on last year. This vendor was late, so we ended up losing 5% of what we were budgeting. But a data lake of certain information, maybe weather reports because your vendor is far away, maybe the purchase orders that were actually generated, maybe the sales order, maybe all this information that comes together so a data scientist can come in and analyze it and show that we should adjust the budgets based on the performance of these vendors because this is how they perform. And a data lake gave us the higher fidelity. We were able to dial that in a lot more precise. And because we're more precise with that information, we can adjust this budget by increasing it 3%, or we can reduce costs by 12%, expanding the plus side of the budget. Now, I get it, that was a very complicated example and it kind of goes around, but my point is, at no point in time did I mention compute, data storage, system interoperability, none of that stuff. I didn't mention any of that. I mentioned things that are important to the business, and they have to understand how data lakes will help them solve a problem or improve their position in order to even want to entertain it. Because to them, it's just something else. It has data in it. It's the same thing. A data lake, data warehouse, we don't care. We've been here a long time. The sun's not outside anymore. So I understand everybody's drained and it's the end of the day. If you have no more questions, I will not be offended. But as long as I'm here, I'm willing to answer any other questions you have.
Well, me, I know because data lakes are mine. So.
And why not? Why not, Mookie? Why don't you like it?
That is not part of the tech stack I handle at all. Yes.
But you know, your part is very important to the data lake because it's the means by which we generate all this information that we put into the data lake. Or one of the means. Yes, sir.
What is the relationship, what is the plan of Qosil as a platform, to support data storages and interfaces between them. What is the plan, or maybe already some ready functionality for that?
So, Qosil is the answer to the problem of having to address all of these things that I mentioned yourself. Qosil has built within it the means to implement data governance, security. It has the built-in tool for data discovery. It provides the means to perform the data distillation that have your data sets or your result sets ready to be ingested by any visualization tool you need. That's the only part that we really don't worry much about, is the visualization of that data, the visualization of the analysis of that data. We let you have that.
Do you not have, the own visualization tools or dashboard?
We're compatible. We're compatible with a number of data visualization tools,
But not yourself.
but not itself. We don't have a problem with data visualization. Plenty of tools out there. That space is well covered. But what we do offer is the ability to allow you to benefit from your work. Your result set can be made available to other people, and you can benefit from that financially. You can make your result set available in the marketplace to be consumed by other systems, by other people, outside of your domain. And right now, there's not many places that allow us for that. Of course, there are data marketplaces out there, but again, that's just a marketplace. It doesn't give you the tools that you need in order to even generate your result sets to begin with. It doesn't give you the structure to go in and process your data through a data lake with all of the points that we've discussed covered. And this is what the Qosil platform will do. All right? Yes. Okay, yeah, because I'm ready to get down from here. Thank you very much. Thank you for the opportunity. I enjoy being in Central Asia. Don't know when I'll be back, but I'm glad I'm here. All right, guys. So I'm going to go get food. We're going to know that I'm done